All right, so today what we're going to do is we're going to continue looking at fractions, guys, and we're going to look at solving problems involving fractions. So what we're going to do is this is going to refer back to finding a fraction of an amount, which is what we did last time. So let's start by just recapping a little bit of what we did. So remember that if you have some fraction a over b, what does that literally mean? A what? Divided by b, exactly. A fraction is actually a division problem, right? And because of that, we know that we can use division when we're working with fractions. So, say for example, and again, I'm just going to use a's and b's and c's and things to do this. So, if we have, times some fraction of a number, right? Then what we can do is use the fact that fraction means to divide to be able to find the fraction of a number. Remember what we did? We took our c, the number that we're finding a fraction of. We took our c and divided it by what? B. The b, the bottom. It's always the bottom, right? Okay? Right? And then we did that first, divided that first, and then what about the a? We multiplied times the a, right? Okay, do you remember that? That was the pattern that we used for solving those last time. So when you're finding a fraction, and this is how to find a fraction of a number. Yeah, it couldn't hurt. It's the notes from last time. It's all in the notes from last time, but it's just a recap, just to remind you. And the reason why I needed to recap it is because we're gonna expand on this idea today, and sometimes it can be difficult to see if you don't remember what we did last time, right? So, if c is our number, right? And we want to find a fraction of it. So remember we did several of these. So say we have 3/4 of 12. Remember that? And remember that word of, if you're talking about fraction of a number, that means you're multiplying, right? So that's 3/4 times, sorry, I keep using the dot for multiply, but remember I told you have to be flexible enough. The 12. So what did I do? I took I turn the oven to the multiplication, right? And then I'm going to take the 12 and do what? Divide it by the 4, good. Which gives me a 3. And then I'm going to multiply that 3 times the 3 on the top there, which gives me what? 9. Right? So fraction of a number. Just divide and then multiply by the top. Now, if that top number is a 1, does it? You don't really look. It doesn't look like you're doing the multiplication, but you really are. 4 divided by 2 gives you what? 2. But 2 times 1 is still what? 2. And that's why we don't usually think about doing the multiplication. Some of you had that question last time, but you really are multiplying. It's just that when you multiply times 1, you get what? The same thing you started with. So it doesn't change anything. So in reality, you're still doing the multiplication. It's just not changing anything, so we just pretend like we're not doing it. Okay? Yes, remember we did one like that too. Remember that we had that one that was going to be a problem if we didn't. So if you have like 3 over 15, 3/15 of something, 25, for example. Okay? Right? We did this one, I think, this very one. And no, we did something else. We did like something. So we did 25 won't divide by 15. But remember the golden rule of fractions is that anytime you see a fraction, you have to simplify it first. So 3 over 15 should actually be what? 1 over 5, right? Remember that? Because 3 and 15 will both divide by 3. So you make it smaller, make them both smaller by dividing by 3. Now the 25 will divide by 5. And, of course, 5 times 1 is still 5, so you completed answer, right? Okay? Good question. So good memory. Remember that if you have something that will simplify, then you need to first. Always first. Okay? Yes, very important. How does that look? Do you remember that? That's what we did last time. Hopefully you've worked on some of them. If not, get some of them done. That clarifies a little bit, maybe. Okay? Keep it simple. It's just the same pattern. All right. Well, today what we're going to do, guys, today what we're going to do is we're going to look at what happens when we're missing other parts. Okay? Because right now, we're looking at what that equals. We don't know what but we know the fraction. We know the number we're taking a fraction of. But what if we didn't know this number? But we did know that number. Do you think that's going to change our process some? Yeah. Yes. If you change what it is you don't know, it's going to change the process some. Now, later as you move forward and you're working with fractions, you're going to learn some what are called algorithms. An algorithm just means a very specific method for working with this kind of thing. You're going to learn how to deal with things that are called equations. And you've had some introduction to equations in your past, right? In year 7, just this much, right? Where you learned what an equation was and the basic idea of an equation. But then later you're going to build on that knowledge and learn more about equations. And so you'll be learning how to do this with an equation. But for now, we're going to do it using logic and problem-solving skills. So you're going to have to think about which piece it is you're missing and what we're going to have to do to find that piece. Okay? And again, it's a matter of thinking about what's missing. So everybody pay close attention to this, because it's not intuitive to most students, at least not all the time. Okay? Are we ready? So let's jump into it. All right. So when we use fractions, we're often missing some important information. So we don't know pieces of information. But we know enough information to be able to find it. I know. You got to have the puppies, right? I don't know what it is about this thing. Okay. So yeah, it makes you less afraid of the math or something. I don't know. So in this lesson, what we're going to do is learn how to solve these problems where we're missing some of the information. So we're not able to take a fraction of an amount because I don't know the amount, or I don't know part of the fraction. Okay, so here we go. So what we're going to do is look at pieces of it. So all right, so here we go. So this puppy is baking some muffins, right? They look more like cupcakes to me, but oh well, that's all right. And I haven't seen many puppies bake cupcakes, but New Zealand puppies are clearly more talented than. Okay, so he's forgotten how many cupcakes he needs. Okay, right? So. But he wanted 2/3 of them to have cherries. So he needs to know how many more he needs. He made 18 that have cherries, right? So he has 18 of his cupcakes that have cherries. And that's all the information we're given right now, yeah?
Can we look it out?
Pardon?
Can we look it out?
So let's see what's going on. Let's look at the information we have. He wanted how many of them to have cherries?
2/3.
So 2/3 of
Should we write it down?
yes, anything that I write down, you should write down. Of the cupcakes should have cherries. Right? Whoops, I can't spell cherries. All right, should have cherries. So that's the fraction of the cupcakes that should have cherries. He says that he's made 18 with cherries, but is 18 the total amount of cupcakes he wants? No. So he has 18 that have cherries already. but he needs more. Okay? Yes? Okay? No, not yet. All right? So let's think about what it is we're missing then. So what's happening is, I know the fraction. Do I know the whole fraction? You bet. And I know how many cupcakes that's the fraction of, but what I don't know is the total number of cupcakes that he's going to bake. Right? Okay? All right? Okay, you're just dying. Okay, go ahead. Yes. How did you think that? What did you do to determine that?
Well, half of 18 is 9, and then 18 plus 9 is 27.
Okay. So, yep. Did you do it a different way, or did you think of it some other way, or did you have a question?
Oh, no.
Okay. All right. So, what we're looking for then is this total number of cupcakes that he has. So we have this number. This is part of the cupcakes, right? So this is what we looked at last time. We had these two pieces on this side, and so we found that piece. Now we have to do the other way around. Okay? And if you think about what we did last time to get where we were, how can we get the other direction? By doing the opposite. There you go. Okay? So, remember last time we took A over B. We had A over B times C equals D, for just because. Okay? To get the D, what we did was we took C divided by B and then multiplied that times A. Right? So we divided by the bottom number, multiplied by the top number. But this time, I need to go backwards. Okay? So instead of dividing first, what do you think I should have to do? Multiply first. Well, let's see. Okay? But I don't know this piece here. So let's look at the process and see if how we're going to come up with a way to make this. So we know that 2/3 of the total muffins is 18 muffins, right? So what we want to do is find out how many total there are. Okay? So we're looking at 2/3 of what is 18. So that's what we had written down. So if you think about it, if it's 2/3, that means that that's two pieces of the three pieces of the muffins, right? The three just separate parts. We have two of them. So one of them then would be, so we have twice as many as our 18. Oops, that should be don't put a number there. That's just a placeholder for it. So if I was looking for one part, if I take the 18 and divide it by the top number, that gives me one part is only how many muffins? 9 muffins, right? Okay, I'm sorry, 1/3. I don't know why I wrote 9 there. So 1/3 of them is 9. Do you agree?
Yes.
Well, how many thirds makes the whole bit?
9 times 3.
Well, 3/3, right? Okay. So if we just take that 9 and multiply it times 3, that gives us the total 27. Trying to do it exactly the way they're doing it so that you can see the explanation as they go. So, remember, he had 2/3 of the cupcakes, right? So what is 1/3? Well, that's half as many, because instead of multiply by 2, remember at the end, if we had a number at the top, we would multiply that number times 2. But this time we're going the opposite way, so we're going to divide by that top number. Okay? All right. There you go. And of course, if it's divided into 3 times 9 gives you a total of 27. Right? So, now, but you've got to be careful about what it is you're missing. Again, remember, this time we were missing the number of cupcakes. Right? The number we're taking a fraction of. This is called the original number. In other words, that's the number that you're taking the fraction of. Okay? So we're missing the big number, right? In other words, the whole. Do you agree that the whole thing is 27? That's how many total cupcakes there were. And that's what we were missing. The original number or the whole amount. Either way you want to think about it, that'll make that work. But we can also be missing other parts of it. We could be missing part of the fraction. Okay? Or, like last time, we were missing that part. So let's look at another question. All right. They check it by just saying 1/3 of 27 is 9, and he had 2/3. So let's just do it our fast way. 27 divided by 3 is 9 times 2 is 18. Right? So going back the way we were, and 18 is how many he had, so we know that we have the right answer. So you can go back and check it. So look at this one. Here's an example. It says 2/5 of what amount is 6? Okay? So 2/5 of what equals 6? Anytime you see that word is, always associate it with equal. Okay? So 2/5 of what is 6? So here I'm missing my original number. Do you agree? Well, that means I can work backwards and find it. So I'll take 6 divided by what? No, be careful. Remember, we multiplied times the top number. So 6 divided by what? 2. 6 divided by 2 gives us what? 3, right? Okay. And then 3 times, what was it that I normally would divide by?
5.
The 5 gives me what?
15.
So the number that I'm looking for is simply 15. You're just reversing the process. So instead of divide by the bottom, multiply by the top, we divide by the top and what? Multiply by the bottom, because we're looking for a different piece of information. Okay? Do you see the pattern? So you're just going to do it backwards, but that means you have to know how to do it forwards, right? Okay? But if you know how to do it forwards, then you can do it backwards. There we go. And they show it, and they're doing the same thing we did. 6 divided by 2 gave them the 3. So that means it's 5 times larger, so 5 times 3 gives them 15. So the original amount is 15. And then they checked it by taking 2/5 of 15, which gives us the 6. Okay? How does it look? So you're going backwards. Now you're going to have to practice this, and you're going to have to know how to do this. All right? So be sure you do. Now, okay? We can also be missing other parts. Cheesecake. Okay? Hey, cheesecake. That's crazy. All right. So, in this case, he's making cheesecakes.
Why is it so angry at the top? Why is it so angry about making cheesecakes?
Well, he's angry at the biscuits.
I just sit there.
Because it says he needs 15 biscuits. Okay? So he needs 15 vanilla biscuits. But he doesn't know how many boxes of biscuits to buy. Guys, come on. Because he doesn't have a box of vanilla biscuits. The box of biscuits is mixed flavors. You guys crack me up. All right?
Why is he so particular?
Well, he doesn't want it. He wants it to come out right. Didn't you know all baking dogs are really picky? Okay. Each box has 12 biscuits, right? So we know a couple of pieces of information, yeah? He needs, hold on. So he needs how many biscuits? 15 vanilla biscuits, right? Each box has 12 biscuits in it, right? Okay, so he needs 15 vanilla biscuits. Each box has 15, but only 1/4 of each box is vanilla flavored.
Oh no!
Okay, which means that there's some other flavor in there, right? Okay, all right. So he doesn't know how many boxes to buy, but here's our key right here, right? 1/4 of each box, and how many boxes and how many biscuits in a box? 12 is, yeah, that's just a straightforward problem, isn't it? That's just 3, right? 12 divided by 4 is 3 times 1 gave us the 3. Yeah? Okay. So that tells us that each box, and notice how I'm writing this out? That's the way you're going to have to write it out when we do an assessment. Yes, I want you to practice. Each box has 3 vanilla biscuits. When we do the assessment, you're going to have to do the math, but you're also going to have to explain what it is you're doing and why you're doing it. In other words, why it is important we need to know why there are 3. Because he only wants the vanilla ones, and each box has only 3 biscuits in it. Yes.
What happens if you can't spell?
Just do as well as you can. Okay? All right. So we know each box has 3 vanilla biscuits, right? Okay? But he needs how many vanilla biscuits?
15.
Well, if each box has 3, how can I find out how many boxes I need to do 15?
3 divided by 15 divided by 3.
Sure. It's 15 divided by 3 gives me 5 what? Boxes. He's going to give them to y'all, of course. All right? So, 5 boxes. Can't eat it. It's dog. All right. So, all right. So we could find a fraction of what we knew, and then we had to multiply to get the rest of it. Okay? All right. But remember, if it says how many boxes, your answer better not be 5. Your answer better be what? 5 boxes, right? Be careful about your units and what you have. Okay? So here we were looking, pardon?
Do we need to have brackets around the units?
No. So, let's look at it. So we did that, but what we were looking for was how many parts of 4 we needed, right? How many of those quarters? How many quarters did it take? Okay. Now, but we did it exactly the right way. I don't like their way. Find out how many vanilla ones there are in each box. Then divide out how many you need to find out how many boxes you need. Okay? All right. It's taking a long time. So here we go. How many 8ths of 32 are in 20? Okay? So this is a very similar problem. We have some number that we don't know, but we're looking at 8ths, times 32 equals 20. Okay? Yes, please do. This is an example we want to work.
Was it a 2 with a dot?
What the? Oh, this is a question mark.
All right.
Yeah, mine is. I don't know what theirs is. Okay. All right. So how many 8ths of 32 are in 20? Okay. So what we're going to do is we're again going to think of this at the same way that we thought of it before by doing the opposite. Because we know a process for this side of it, don't we? Okay. But we have to use this number as well. So let's look at our process. Okay. It's easy to calculate 1/8 of 32, right? 1/8 of 32 simply means take 32 divided by 8 gives us what?
4.
Yeah, 32 divided by 8 gives us 4, right? Okay. Do you agree? And then we would usually take 4 times that top number to get our D or our new number, that new number. But we can't multiply it times the top number this time. Why? Because we don't know what the top number is. Yeah, we don't know what the top number is. So instead of multiplying to find it, we'll simply use the opposite of multiply, which is what? Divide. Okay? So let's look at the whole thing again using that algorithm, using that process of... Stop that. There we go. So here we go. If we had A over B times C equals D, right? We would take C divided by D, okay, equals some number. And then we would take A times that number, right, to get our D. So think about the way we did it forwards, right? That's the way we did it first. We took the original number divided by the bottom and multiplied what the answer we got. That's the symbol for number right there, guys. Remember, it's a hashtag. Come on. All right? That's the original way. If we know the pieces. But now we don't know all the pieces. We need to find them. So if I have a question mark over 8 times 32 equals 20, so I can still do the 32 divided by the 8 part, right? This part I can still do because I know the number I'm taking a fraction of. I know the number I'm dividing by. So I can still divide that just like I always did. And what does that give me? 4. And then I would take that 4 times something to get 20, right? I would normally multiply it times the top number. But do I know what the top number is?
No.
So instead, what I have to do is reverse the process. So instead of multiply by 4, what will I do? Take the 20 and divide it by 4. And that will tell me the top number. Okay? So if you're missing a piece, to find that piece, you must go backwards. Use the opposite. Okay? All right? So it's the same thing that they did with finding one of those 8s, but instead of finding one of those 8s, we can just do it using the same process, going backwards. Okay? Does everybody have that written down so I can go to the next example and we can look at these?
Yes.
Okay? So we'll need to make sure we look at everything. Okay? And then you can check it if you want to make sure. Let's see. So that's solving for the numerator, which is the top. You can also solve for the denominator. Okay? No, it's not. It's no harder. Just remember that normally you would divide by the denominator, then multiply by the numerator. But if you're working backwards, you're going to have to go backwards. Okay? So here he goes. He got a box that has 5 cookie cutters in it. Making a lot of different shapes of cookies. Yes. Sure. Oh, that was 4 times question mark. I'm sorry. Yeah, that was a question mark. Yeah. Sorry. Me and my question marks look like too much like 2s, don't they? I'll try to do better. Question mark. Is that better? Oh, guys. I don't know how.
It's good enough. It's good enough.
It's good enough. Okay. Question mark. All right, here we go. Come back with me. All right. So he got a box with 5 cookie cutters in it, right? But he ordered 35 cookie cutters total. All right? So he ordered 35, but he only got 5. So what they did was they split his order up. So if they split his order up, what do you assume then? That they split his order up how, you think?
So they put 5 cookie cutters in each box.
There you are. So if they put 5 in each box, and there are 35 total, how can I find out how many boxes there are then?
You go 5 divided by 5.
Well, the other way around though. 35 divided by 5 gives me how many? So that tells me that there are 7 boxes of cookie cutters. Okay? And he's gotten how many of them?
1. It's over 6.
Which means how many has he have? So he still has 6 to go, right? So in other words, he has 1/7 of his order, right? And he's still expecting what? 6/7 of it, right? So he has 1/7. So he's still waiting for 6/7 of his order. Okay? Does that make sense?
Yeah, it does.
Okay? So if you know how many the big total of it is, and you know how many parts you're dividing it into, then it's simply just a matter of dividing into those parts. Right? So we did that division. 35 divided by 5. They took us around a long way to get there, but gave us 7 times that many, right? Okay. So that means the cookie cutters were divided into 7 equal groups of 5. Now, why he would want that many? Maybe he was giving them away. Who knows? Okay. So 1/7. So he's waiting for 6 more. So 6 more parcels.
I'd be really
All right.
mad.
Whoops. Here we go. So let's look at... Hold on. Pushed one too many buttons. So here we go. Then let's look at this other example. So we have a cake. It's covered in 40 cherries, and it's been divided into pieces. 3 slices have 12 cherries. All right? There's our key right there. Just like the box a while ago, right? 3 slices has how many? 12 cherries, right? Which means that each slice has what? 12 divided by 3, which is 4. Yeah. So each slice has 4 cherries. If you know, right, how many little pieces there are, then you can simply divide it up to find the rest of it. Okay? Okay? So each slice has 4 cherries. Do we agree? Okay. And the cake has 40 cherries total. Okay. If each one piece has 4 cherries, and there are 40 cherries total, 40 divided by 4 means there are what? 10 what? 10 pieces of cake. Right? Make sense?
Yes.
If I gave you, if you're dividing out something evenly, then it has to stay even and divided into even pieces. So if I know 3 of them have 12 cherries, then there are 40 cherries total. Each piece has 4 cherries, and 40 divided by 4 gives us a total of 10 pieces. So divided into 10 pieces. Okay. Now, again, you can go back to your algorithm with that. That's 3 over our B we didn't know, right? Times 40 equals our 12. Normally, we would take 40 divided by B equals some number, but we can't, okay? And then 3 times that number would equal 12, right? So thinking of it as doing the opposite, what is the opposite? If it would have been 3 times that, that means that the opposite of multiply is what? What's the opposite of multiply? Divide, right? So 12 divided by 3 gives us what? 4. So that tells that this number should be 4, right? And we would normally divide to get that number, but we have to do the opposite.
Divide as well.
So what we have is we're dividing by some number to get that Okay, our normal opposite, our number is divide, so to get a 4. So something divided by 4 would be,
All the numbers.
what would you multiply 40 by? That's what I'm trying to say. What would you multiply 4 by to get 40? And that's 10. Okay? So it's still doing the same process. So if you want to think of it the same way, you can think of it the same way every time as well. Just use letters to stand for the things you don't know. Not question marks, because I can't make a question mark. So we'll use letters. Yes?
Yeah.
All the cherries like really.
No, each slice only has 4 cherries.
Oh, I read.
3 slices had
I read
12.
the question.
Okay? All right. Now,